Okay, so talking about graphing parabolas and writing equations for parabolas, again, and this time we're going to focus on given 3 points. So the title of this is writing the equation for parabolas when given 3 points. Now, think about this. A satellite dish has a diameter of 12 inches and a depth of 2 inches. Where should the engineer place a receptor so that it receives the best signal? So if you think about this, whenever you give you a word problem like this, you want to start off by drawing a picture to represent what's going on. So I'm going to draw a picture of a satellite dish. And this is my satellite dish. And it said that the diameter is 12 inches. So I know this length here is 12 inches. And it said the depth is 2 inches. So this space is 2 inches. So no, I know that for sure. It'd be great to go ahead and know the radius. This has got to be 6, and that's got to be 6. Given that, I know all the information. I'm going to redesign it so that it's laying flat at the origin. We assume that this is like the origin. 0, 0 would be the vertex of that. So if that's the case, I know this piece is 6, this piece is 6, and this piece is 2. And if that's the origin, that coordinate is 0, 0. And technically, if this is 6 and that's 2, I know I have to go over 6 and up 2 to get to that point. And over here, I have to go to the left 6, so negative 6 and up 2 to get to that place. So I got 3 points, and I can actually write equations for it. But since I know the vertex of it, it's better than just any 3 points. Like if I had this point, that point, and maybe this point, I can write the equation for it. But it's easier if you actually know when the vertex is at 0, 0. So in this case, I know that it's the parabola that's written with x squared equals to 4py. And basically, I want to know where I should put the receiver at to get the best signal. So indirectly saying, where is the focus? So that's the question you ultimately answer. Where is the focus at? So I know in this, if it's facing this direction, it should be somewhere on this axis of symmetry here. So let's get this straight. I got points all over the place. I'm going to choose this one. 6. All right, so in this coordinate, this is an x coordinate, this is a y coordinate. So I know x and y are in this formula. So I know x has to be 6. So it's going to use 6 squared equals to 4p, which what we want to find. And the y value is 2. So we get 36 equals to 4 times 2 is 8p. So if that's the case, what we have now is I got to divide that by both sides by 8, so 6. So divide both sides by 8 here and here. So 36 divided by 8. So 32 is 4 times 8. You got 4 left over. So p is 4.5 or 4.5. So I know that if that's the case, I know that my receiver has to be 4.5 away from this point. So from this point, I can go up 4.5. This is 2. This is about 2.5. Somewhere around there. So basically, you want a receiver that's 4.5 inches long, so that you can get it at the point where it's going to receive the greatest signal. So anyway, that's how we can actually write an equation for a parabola. So technically, if you wanted to, you can you can create a satellite. If you knew how big the dish was, if you can measure how far across that bowl was, how deep it is, whatever, you can actually place the receiver actually where it should be, so you can receive the most light. And you can actually do that. You can actually do that on your own, actually finding, creating something that gives you the most light. So, or gives you a radio signal or whatever. So nice little thing to know. So anyway, with that being said, I'm going to leave this alone, and we're going to talk about having 3 points, and one of those points won't be the vertex. One of those points will be some other point, not including the vertex. So let's talk about those now. All right, so write the equation for the parabola that has the points 1, 6, 2, 7, and negative 4, 11. Notice it didn't recognize any of these points being the vertex. All these points exist somewhere on the parabola. So to actually do that, let's first think about the equation y equals ax squared plus bx plus c. All right, so if I chose point 1,6, and this is x, and this is y, I plug those numbers in, I would get 6 equals to a times 1 squared plus b times 1 plus c. Well, that means 6 equals to 1 squared is 1 times a is a plus b times 1 is b plus c. So 6 equals a plus b plus c. Because I have 3 variables in this equation, I need 3 equations. I need a system equation and 3 variables, so I need 3 equations. So I need a second equation. Find that equation using 2,7. So at 2,7, using the expression y equals ax squared plus bx plus c. So that's going to be 7 equals, because this is x, this is y, 7 equals a times 2 squared plus b times 2 plus c. And this gives you 7 equals to 4a plus 2b plus c. So that's the second equation. I need a third equation, so using this point now, negative 411. So at negative 411, I will wind up getting x, and this is y. So it would be y equals to, well, better yet, y equals ax squared, x squared plus bx plus c. So 11 equals to a times negative 4 squared plus b times negative 4 plus c. So 11 equals to 16 a squared, subtract 4b plus c. So I got one equation, a second equation, and a third equation. And I got 3 equations which I needed to answer the equation in 2 variables. So this is like a plus c at the end, so that's 2b plus c. So anyway, those are 3 equations you need to actually answer it. So you actually need a system of equations in 3 variables. So I need all this space. So if you need any of this, I need you to go write that down now so I can erase this stuff. But I do need to erase it so I can rewrite these things. All right, so we can solve this by hand algebraically. However, this is a perfect opportunity to teach you a new math concept called matrices. How we can solve this using our calculator, if you have a TI calculator, and you understand a little bit about matrices. So this is what you need to know about matrices. A quick little lesson on matrices just for these type of examples. You can rewrite this column, 6, 17, and 11, as a matrix. And you can rewrite all the coefficients here as one matrix. So you should rewrite the first coefficients that are 1 and 1 and 1. So the coefficients here are 1, 1, and 1. The next group of coefficients are 4, 2, and 1. So 4, 2, and 1. This is 16, negative 4, and 1. 16, negative 4, and 1. And the A, B's, and C's all set up in nice little order. They're already in the right order. So this matrix is times the matrix A, B, C. Now, the order you use matrix, you got to know a few things about them. One thing you need to know about this is organizing rows by columns. So rows by columns. And if you notice, this is a row, this is a row, this is a row. Rows go horizontal, columns are vertical. So this has 3 rows and 1 column. So this is a 3 by 1 matrix. This one has 1, 2, 3 rows and 1, 2, 3 columns. So this is a 3 by 3 matrix. And this is 1, 2, 3 and 1 column. It's 3 by 1. So let's get this straight. Let's name these things A. Let's call this one B. Let's call this one matrix C. So let's get that clear. Now, in order to isolate the variables, which is the C matrix, you want to multiply both sides by the inverse of the A matrix. If basically you want to solve an equation just like this, you want to multiply both sides by the inverse. Prime example, if I gave you 3 times x equals a 2, if I actually solve for x, you probably say, oh, I divide by 3. But technically what you're doing is you're multiplying it by the inverse. The multiplicative inverse of 3 is 3. So you multiply both sides by its inverse, you get 1/3 times 3, well, that's 1. And that's going to be 2 over 3. So that's what you get when you multiply by its inverses. So if I multiply a times a's inverse, that little -1 means inverse, I get the matrix equivalent of 1. And the matrix equivalent of 1 is the matrix with 1s as a diagonal, and everything else been zeros. So make that look a little better. So you got 1, 0, 0, 0, 1, 0, 0, 0, 1. So anyway, this is called the identity matrix. In matrix world, this means 1. So you multiply that by anything, it doesn't change it, so it treats it like 1. So basically, understand this. If I have this equation, which is B equals to A times C. If I want to solve that, I have to multiply the left side by A inverse, multiply the right side by A inverse. A inverse times A is 1C. So I get C equals to A inverse times B. Which you can give me answers for. So basically what I want to do is take out my calculator, plug in matrix A, plug in matrix B, and then multiply A inverse times B. That is my goal, to figure out what A inverse times B is. So take out the graphing calculator now. And get all this stuff written down someplace so you can actually type it into your calculator. Alright, so in order to use this, the first thing you need to do is go down to matrix. So here's matrix right above X inverse. So hit second, X inverse, go to matrix. Alright. So after you get into the matrix, go over to edit, and then this is matrix A. If you take a look at matrix A, it's got 3 rows and 3 columns. It's 3 by 3. So enter 3, hit enter for 3, enter, 3, enter. So it's a 3 by 3 matrix, and you have all the numbers put in. Just type in the numbers: 1, enter, 1, enter, 1, enter. It takes you to the next row. 4, enter, 2, enter, 1, enter. And then 16, enter, -4, enter, and 1, enter. So that's matrix A. If I hit second mode to quit, if I want to check that, hit second matrix, second X inverse, hit enter, and enter again, and it shows you what was in matrix A. Do the same thing for matrix B. So go down to matrix, go over to edit, and then go down to B. After you go to edit, hit enter. It's 3 by 1, so 3, enter, and 1, enter. And the numbers are 6, 17, and the last number is 11. Alright, so after you do that, you get second mode to quit. You got B plugged in. What you want to plug in is A inverse times B. So type in matrix A, hit enter. This is the inverse button. This is the X to the -1, so tap it. Times, go down to matrix again, go down to the number 2 for B, hit enter. A inverse times B, and it tells you 2, 5, and -1. That's the values for A, B, and C respectively. Alright, so that matrix A, B, and C equal to the numbers 2, 5, -1. So that means that A is 2, B is 5, C is -1. So the equation is y equals to 2x squared plus 5x subtract 1. So that's it. I guess you make that green. So that's it. That's how I can write an equation for it. That's all you need to know about it. If you got more questions, please bring them to class tomorrow. In the night's homework, you may want to take a look at that again. That's a lot of steps involved, and plus you learn this new thing about matrices and stuff. So yeah. Just real quick, if I gave you this matrix, 1, 2, 4, 6, 2, 1, 1, 3. What's the dimensions of it? As in 3 by 1, 2 by 1, and so forth. Right, so if you said 2 by 4, you're right. So anyway, that's all I have. Good luck.